Hi, in this video we're going to do a 3 loops RLC circuit transfer function. We are going to use node analysis method with Cramer's rule. So on my whiteboard there is 2 circuits. The top circuit is the circuit in the time domain. Your first step is you need to convert the circuit in the time domain into the S domain circuit, and I have already drawn that S domain circuit. So the time domain power supply is VT. It will become VS in S domain. Output voltage V naught T in time domain will be V naught S in S domain. Next one, for the component resistors, the impedance is the same value as in the time domain. So it remains as 3, 4 and 5 for the resistors. For the capacitor, in the time domain if it's 5 farad, then in the S domain it will become 1 over 5S. In the time domain, capacitor is 1 farad. Converted into S domain, it will become 1 over S. And for the output component, which is an inductor, in the time domain, it is given as 2 Henry. And converted into S domain, it will become 2S. So now you have your S domain circuit. Next one, we want to mark our nodes. In this circuit, you will have 3 nodes. Node number 1 can be named as V1S. Node number 2 can be named as V2S. And node number 3, look at the position. It is across the load component, which is equals to V0S. So we keep the name as V0S. Okay, the first node, which is the most left node, it is VS because there's no other component. It's the same as the input supply potential. So it is VS. So now that you have the 3 nodes, V1, V2 and V0 S, next one, we're going to come up with the node equation. So we're going to do node number 1. Node 1. Node 1, you have 1 current in and 2 current out. Okay, so on my circuit, I have actually drawn that yellow or orange line, which denotes the 0 volt grounded line because it is connected to the negative supply. So it is denoted by 0 volt. Okay, so back to node equation. Node number 1. Okay. 1 current in, 2 current out. Current in is V1S minus V2S over 3 equals to V2S minus V1S over 4 plus 0 minus V1S over 1 over 5S. On your left hand side, you should just leave it with VS terms if there's any. Okay, so right now for node 1, you have that VS term. So leave it on the left hand side. And then for the rest of the terms, bring it on the right hand side. But please make sure your arrangement is according to V1, V2 and then V0. Arrange it in that way. Okay, so there is the common terms, which is V1S. Put them together. Okay, so right now I want to simplify my circuit so that the left hand term will be just left with Vs. Okay, but first make sure that this term here is being simplified first. So here you will get 60s plus 7 over 12. Okay, so now I'm going to simplify it to become just Vs on the left hand side. So you will get 60s over 7 over 4 V1s minus 3 over 4 V2s. So this is equation 1. Okay, so this is equation 1. Equation for your node 1. Vs equals to 60s plus 7 over 4 V1s minus 3 over 4 V2s. So moving on, we want to do equation for node number 2. 1 current in, 2 current out. So current in, current out. Okay, so now try to put the common terms together. Okay, so since we don't have Vs term for this second node, meaning that your left hand term should be no Vs, so it will just become 0. So on the right hand term, it should be V1, V2 and V0. Okay, so if there's no Vs, your left hand term will become just 0. And you should bring the rest of the terms to the right hand side. So it becomes 0 equals to since you have the common V2 term, so you need to simplify that. Okay, so since your left hand term is just 0, so you can actually further reduce this equation, or you can just leave it as it is. So if you want to reduce it, you have to make sure that the denominator for each of the 3 terms on the left hand term is the same. So right now you can actually change the term, make sure the denominator for the first term and the third term is equals to 0. So what happens is it will become like this. Okay, so now that you are already here, okay, next one, you can multiply 0 with 20. So you will be left with equation 0 equals to 5v1s minus 20s plus 9 v2s plus 4 v0s. So this is your equation number 2. Okay, so equation 2, 0 equals to 5v1s minus in bracket 20s plus 9v2s plus 4v0s. Next one, we're going to find equation for node number 3. Okay, so for node number 3, we have one current in and only one current out. So current in V0S minus V2S divided by 5 equals to current out 0 minus V0S divided by 2S. Okay, so you can bring everything to the right hand side. Now you have a common V0S term, so put it together. And you will get an equation of 0 equals to V2S over 5 minus 10s plus 5 is 2s plus 5 divided by 10s. So 2s plus 5 divided by 10s V0. So this is equation number 3. Okay, so now you're done with the equation for each node. So you have equation for node 1, which is equals to Vs equals to 60s plus 7 over 4 V1s minus 3 over 4 V2s. And then equation number 2, 0 equals to 5 V1s minus in bracket 20s plus 9 V2s plus 4 V0s. And then equation number 3, which is 0 equals to V2s over 5 minus in bracket 2s plus 5 over 10s V0s. So once you have gotten all 3 equations, we will put it in matrix form. So you will have a 3 by 3 matrix and 3 by 1 matrix. So this is your 3 equation. Equation 1, 2, and 3. Okay, so now let's put it in a matrix form. So on your left hand side will be the term for the left hand side term, which is Vs 0 and 0 equals to, okay, so now we're going to do it by each equation. So the arrangement is such, arrangement is V1s, V2s, V0s. So this is the correct arrangement or for the 3 equation. So for equation 1, put in the equation term by term. So So for term V1s, it is 60s plus 7 over 4. For the V2s term, it is negative 3 over 4. And since it doesn't have a V0s term, so the V0s term is equals to 0. Second equation, term for V1s is 5 V1s, negative 20s plus 9 for V2s, and then 4 V0s for the third term. For equation number 3, you don't have the term for V1, so meaning it is 0. And term number 2 for V2s is 1 over 5. And term number 3, which is for V0s, is negative 2s plus 5 over 10s. Right, so right now you have this 3 by 1 matrix equals to a 3 by 3 matrix multiplied by a 3 by 1 matrix. What we want to use here is we want to use the 3 by 3 matrix. So this is the important one. Okay, so now we're going to use Cramer's rule. Since our goal is to find the output voltage, okay, meaning that in our 3 by 3 matrix, the V0s term is multiplied by this column. Okay, in the 3 by 3 matrix, the third column is the term that is multiplied with V0s. So you need to replace this column with the left hand side column. Okay, so this is the special matrix. So V0s equals to determinant of a special matrix, and that special matrix is this. Okay, so V0s equals to the special matrix, determinant for special matrix divided by determinant of the original matrix. So write down your original matrix. Okay, so this is Cramer's rule. To find V0s, using Cramer's rule to find V0s. Next one, we want to find the determinant for the top matrix. You can choose any row that you want. So I'm going to choose my first row. So you can actually refer to your matrix notes how to find determinant of a 3 by 3 matrix. Okay, so this is the arrangement to find the determinant for a 3 by 3 matrix given that you choose the first row. Okay, the arrow that I am drawing is actually to show how to find the determinant for this 2 by 2 matrix. It is AD minus BC. AD minus BC. AD minus BC. So the arrangement for ABCD is as such ABCD. So if AD minus BC, that's why it is like a cross. Okay, you multiplied it crossed. For the first term, AD minus BC is 0, so it becomes 0. For the second term, AD minus BC is also 0. And the last term, you have 5 multiplied by 1 over 5 minus 0 multiplied by negative 20s plus 9, which is a 0. So you get your determinant equals to Vs. So determinant for the top matrix is Vs. Okay, so next one, we want to find the determinant for the original matrix. Similar method. I am also going to select the first row. Okay, so determinant for bottom matrix, the arrangement is as what I've written. The third term is equals to 0 because for the first row, the third term is 0. So solve this. Okay, so now that you have this equation, you need to expand this. You need to expand this. So it is quite lengthy. Okay, so it is quite lengthy. So you need to multiply this, all these brackets. All the terms in the brackets must be multiplied and then must be Simplify. So eventually you will get an answer Okay, so once you have already multiplied those in bracket, you will get this answer as the determinant for your bottom matrix. So 60 s cubed plus 172 s squared plus 86 s plus 6 divided by s. Now you have both the determinant for bottom and top matrix. We can now arrange our answer. So V naught S equals to determinant for the top matrix, which is Vs, divided by determinant for bottom matrix, which is this. V naught S equals to Vs divided by 60 s cubed plus 172 s squared plus 86 s plus 6 divided by s. Rearranging this equation, V naught S, we want to find V naught S over Vs, which is output voltage over input voltage. And you will get an equation of S over 60 s cubed plus 172 s squared plus 86 s plus 6. So this is your transfer function for the 3 loops RLC circuit. You may reduce this further to become V naught S over Vs equals to S over 60. Okay, so you can actually do this, or you can just leave the answer as it is. Okay, so both answer is accepted. So you can write down your final answer as V naught S over Vs equals to S over 60 s cubed plus 172 s squared plus 86 s plus 6. Or you can also reduce the value for s cubed to 60 s cubed to just s cubed. So your final answer can also be V naught S over Vs equals to S over 60 over s cubed plus 172 over 60 s squared plus 86 over 60 s plus 6 over 60. So both answer is accepted. So this is the solution for a 3-loop RLC circuit using node analysis and Cramer's rule. So going from the top, I'm going to summarize the step. First step, convert your circuit into an S-domain circuit. And then second step, find the equation for each node. In this case, we have 3 nodes. Next step, you have to rewrite the 3 equations into matrix form. Fourth step, you need to use Cramer's rule to find V naught S. Cramer's rule, using Cramer's rule meaning that you need to find the determinant of the 3 by 3 matrix. Once you have gotten your determinant for the 3 by 3 matrix, you can put the equation back into You can put the equation into its respective arrangement, which is determinant for top matrix divided by determinant for the bottom matrix. And by the fifth step, you should get the equation in terms of V naught and Vs. Rearrange that equation and you shall get your transfer function of your 3 loops RLC circuit, and that's it.